Hi friends, welcome back. Today we are going to solve one interesting Leetcode coding question 2368 reachable nodes with restrictions. So this is quite recent problem on Leetcode that I came across and I solved it and I just thought that it's worthwhile to create a video and show you how we can solve these kind of problems. So we are going to solve this problem in today's session. We'll go through the problem, we'll understand with this problem with some examples, and we'll also implement the Java solution for this problem. Before we start looking into the details of these problems with some examples, I would like to mention that this channel is to help people in their coding and Java interviews. On this channel, you will find more than 500 different varieties of coding problems solved and explained with whiteboarding sessions, examples, and Java code. Many of those problems are taken from previously asked coding interview questions by big tech companies including Google, Facebook, Amazon, Apple, Microsoft, Yahoo, LinkedIn, Uber, Lyft, Netflix, and many others. Among those solved coding problems, you will see all important coding questions varieties are covered in them. That includes problems related to breadth first search, depth first search, graphs, matrices, binary search trees, optimization problems, linked list, strings, related problems, problems related to dynamic programming, as well as lots of logical questions. On this channel, you will also see a lot of very important data structure related coding interview questions also solved and discussed on this channel. For example, questions related to stacks, queues, priority queues, hash table, hash map, tree map, hash set, linked hash map, linked hash set, as well as many other important data structure related coding problems are also available on this channel. So if you are preparing for any coding rounds of interviews or Java rounds of interviews, or you simply want to learn different concepts of computer science, different algorithmic paradigms, techniques, data structures, problem solving, logic building, Java coding, then this channel can definitely help you in doing so. So please subscribe to this channel now. Also, whenever we come across any important coding problems or coding challenges like this one, we often create videos on this channel to discuss the problem with the solutions, so others can also learn how to solve different coding problems, and they can also learn how to implement the solutions using Java language. So make sure you click on the bell notification icon so you won't miss any important postings from this channel. So let us start with the reachable nodes with restrictions problem, Leetcode 2368. So we'll first go through the problem statement so you'll completely understand the problem. So let's start. There is an undirected tree with n nodes labeled from 0 to n minus 1 and n minus 1 edges. So it is a undirected, basically. This is important, right? You are given a 2D integer array edges of length n minus 1 where edges of I is between ai to bi, indicates that there is an edge between nodes ai and bi in the tree, and that is a undirected, right? So what it means is, if there is a edge from a to b, then it means that there is a edge from b to a as well, because it's a undirected graph, or right, that's why. You are also given an integer array restricted which represents restricted nodes, so this is important, so that is also given to us. Now return the maximum number of nodes you can reach from node 0 without visiting a restricted node. Note that node 0 will not be restricted node, right? So they have given some examples, so we'll see these examples. Let's take a look at the constraints. So n is number of nodes which will be between 2 to 10 raised to 5 inclusive, so it can be very big graph, right? 10 raised to 5 means edges dot length will be n minus 1, edges of I dot length is 2, because this edges I dot length is 2 because it contains two nodes, right? From edge and to edge. So edge is from that node to the node, right? And 0 is less than equal to ai is and bi, and it is less than n. Ai is not equal to bi. Edges represents valid tree, and 1 is less than equal to restricted dot length is less than n, and all the values of restricted nodes are unique. So these are the constraints that are given to us. So basically, let's take a look at some examples so it will be clear to you what the problem is asking us to do. So this is basically they are talking about tree, but you can also look it as a graph also, right? So basically they are asking us that there are two nodes given to us, which is 4 and 5, right? So these are restricted nodes, so it means that you cannot go through these nodes basically. right? So you cannot go from 0 to 5 and 5 to 6. So this is not possible. Basically you cannot go from 0 to 4. This is not possible because 4 is restricted, 5 is restricted, correct? So what are the nodes then you can visit? Then you can visit 0, then you can visit 1, then you can visit 2 and 3. So these are the nodes that you can visit because these are not restricted nodes, right? So they are asking us to count these kind of nodes which we can visit basically. So now in this case we can visit node 0, 1, 2, 3. So total nodes, how many we have found? 4. So that is what we have to find an output. The total number of nodes, correct, that we can visit. So this is what the problem statement says. So this is another example where 1, 2 and 4 are restricted nodes, right? 1, 2 and 4 are restricted nodes. If 1, 2 and 4 are restricted, then what nodes we can visit? So you cannot go from 0 to 2 and 2 to 3, right? Because 2 is restricted. You cannot go from 0 to 4, you cannot go from 0 to 1. Because these 1, 2 and 4 are restricted nodes. So you cannot visit those nodes, correct? And since you cannot visit 2, it means that you cannot go to 3 from 0, right? So what nodes then you can visit? You can visit these other nodes. You can go from 0 to 5 and 5 to 6 because these are not restricted nodes. So how many are these nodes? 3, right? 3 nodes, 0, 5 and 6. So total 3 nodes. So this is what we have to output. So this is what the problem statement is asking us to do basically, correct? So now how we can solve this coding problem? So one way to solve this coding problem is we can build a adjacency list, right? Which is essentially a representation of graph, right? Adjacency list. So what is adjacency list? So adjacency list is, it tells us what are the neighbors of the corresponding node. For example, for 0, this is the adjacency list for node 0, correct? This is the adjacency list for node 1. This is adjacency list for node 2. This is for 3, this is for 4, this is for 5, and this is for 6, right? So this is the adjacency list. So what does it tell us? So it tells us how which are the neighbors of 0. So 0's neighbors are 1, 4 and 5, right? 1, 4 and 5. What are the neighbors of 1? 0, 2 and 3, right? 0, 2 and 3, correct? So like this. What are the neighbors of 2? Neighbors of 2 is 1, right? Neighbors of 3 is 1, neighbors of 4 is 0, neighbors of 5 are 0 and 6, right? And neighbors of 6 is 5. So this is the adjacency list that we will create first, correct? Which is essentially, you can also say that we are basically building a graph basically, right? Adjacency list is a depiction of graph, right? So this is how we can represent graph internally in the coding, correct? So now once we have the adjacency list built, then what we will do, we will do DFS, right? We will start doing DFS. So DFS stands for depth first search or depth first traversal, correct? So this is one very important programming technique that we can use it on trees as well as graphs, right? So what DFS does is we can start DFS from node 0, right? So how DFS goes, it goes like it takes one path and it goes completely in depth to that path. How it works? So 0 to 1, then it will go all the way till depth, all the depth it will go. So 1 to 2, then it will come back to 1 and it will take this path. So this another path, then it will go back to 0, then it will visit 4, then it will go back, go to 0 and it will visit 5 and 6. So this is how DFS internally works, right? So it goes in depth. That's why it is called as DFS, right? So how will DFS help us solving this problem, and how will we actually handle the restricted nodes? Typically what we do in DFS implementation is, one important thing we always do is we keep track of the visited nodes, right? Visited nodes we keep track, correct? We'll keep track of visited nodes using a visited array. And why do we use this visited array? Because once we visit a node, we don't want to revisit it again and again, correct? We don't want to revisit that node. So what we will do, that this, for example, in this case 4 and 5 nodes are restricted, so we will first add these nodes into this visited array, correct? It means that we have already visited nodes. Why we are doing it? So we are simulating that we have restricted these nodes, so we cannot visit those nodes again, basically, correct? So once we know that we cannot visit these nodes, then there is no way we can go from forward from 5 to 6, for example, correct? Because those are already visited nodes. So this is the way we are going to simulate the restricted nodes using DFS approach, correct? So we'll add those restricted nodes in the visited array first, and then we will start doing the DFS, right? Now once we have this restricted nodes added into visited nodes, for example 4 comma 5 is added into visited array, then we'll start doing DFS from 0, correct? Then it will go to 1, right? Then it will go to 2, and from 1 it will go to 3, and at the same time we will keep track of the number of nodes that we are visiting, correct? We will keep track of a counter, right? Counter. So here how many we visited? 4 nodes we have visited total, correct? 4 nodes. So this is how we will know how many nodes we can visit from 0, correct, which are not restricted nodes, right? So this is the way we are going to solve this problem. So I hope it is clear to you now with this example and explanation. So more will be clear once we look at the code. So let's go to the code now. So this is the code for reachable node. So we are going to get n here, right, which is number of nodes. Edges is the edges, which is the edges is given to us, right? Restricted are the restricted nodes, right? First thing we are going to do in the implementation is we are going to create a adjacency link list, right, which is a depiction of a graph. So we are basically building a graph here, right, which is link list of integer. It is an array of link list, correct? Why we have array? Because for each node we are going to create the link list, right, for each node. That's why it is an array of link list, right? Now what we will do is we will go from for, like we'll do from 0 to n minus 1. So we are going to go through all these edges and we are going to populate our adjacency link list, right? In another terms, or in computer science terms, we are building a graph now by using these edges, right? So how we are building it? We have two things given, right? Edges I comma 0 will give us from node, and I comma 1 will give us to node, right? Because edge is from node to node, correct? Now we will check if the adjacency link list of from node, if it is null, then we have to create a brand new link list for that node, right? So we will create this brand new link list and then add this to node into that list, and then we will put this to this node into adjacency link list of this source list. We will put it into adjacency link list of from node, right? So basically this is an array, right? Adjacency link list is an array. So this from node will give us the list, and we'll just assign this source list there, correct? So that is what we are doing. So I hope it is clear to you, because in the beginning there will be nothing there, right? So we have to create a list in the beginning, correct? Now if list is already present, then we have to simply get the list for that from node, and then we have to just add two node to it, right? Means we are basically adding a neighbor basically for that from node, correct? Because the age can be, for example, let's say 0 to 1, right? So age is from 0 to 1. It means that there is a, like, we will have to add for this 0 we will have to add 1, and also for this 1 we will have to add 0, right? Because it is a undirected graph, so we have to do both things. This is clear to you, right? So if we are processing a age which is 0 to 1, what we are doing is we have to add into the adjacency list of 0 we have to add 1, correct? And then for adjacency list of 1 we have to add 0, correct? Because it is a undirected graph, so we have to do it both ways, correct? So that is what we are doing here. So that is what we are doing here, right? So if you take a look here, then we are actually in the first thing we did it from node to node, correct? Now we will do to node to from node. So we will do to node to from node, correct? So to node to from node, as you can see here, correct? To node to from node, and here also to node to from node. We have created a new list because it is first time we will not have the list, so we have to create a new list, right? So this way we have actually populated our adjacency link list. In another terms, we have created our graph, right? We have created our graph. Now our graph is ready. After this for loop, our graph is ready. So we'll create a visited Boolean array of n nodes, correct? There are n nodes. So visited array size will also be n. After that, we will go through all the restricted nodes and we will mark them as visited. So this is the way we are simulating that we are excluding the restricted nodes during the DFS, right? Because we don't want to process the restricted nodes when we do the DFS, correct? So it means that we will mark them as a true, right? Then it means that we will avoid processing the restricted nodes. And in the beginning, count is 1. Visited 0 is true because the node will start DFS with a node 0, right? So we'll mark that as a visited here, and then we will just call our recursive DFS function. It is called as find reachable nodes, right? Find reachable nodes is the name of the function. So what it takes source node, right? It takes our graph, which is adjacency linked list, and it takes visited array, and it takes count, correct? Then we go and start processing the neighbors for this source node, correct? We take all the neighbors for this source node here, and if it is not visited, then we are going to visit that neighbor, and we are recursively going to call the find reachable nodes function. One important thing to note here is now the source will be changed to neighbor, right? Because now the source is neighbor, correct? And our count is increased by 1 because now we have already seen one more count here, correct? So we have seen one more count, so count will be increased by 1. So this way it will this is a recursive call, right? So it will keep recursively calling this function as long as it visits all the nodes, right? As long as it visits all the nodes like 0, 1, 2, 3, correct? And then our count will become 4 at that time. So we will just have to return this count, right? So I hope this is clear to you now. So this is the way we can implement our solution using DFS, right? You can also call it as a DFS, this function also, but this is basically a recursive function, right? Find reachable nodes. And one other important thing here is how we have excluded the restricted nodes. We have excluded, simply we mark them as a visited before we start doing the DFS, right? Before we start doing the DFS, we have marked them as a visited, and that is how we are simulating that we are excluding the processing for those nodes, right? Because those are restricted nodes. So let's go ahead, make sure this code runs correct, gives us correct answers. So this is the first test case that we have seen here, right? So 4 is the correct answer. Let's test with another test case. So let's take the second test case that they have. This is the second test case. So we are expecting 3 as the answer. So we are getting 3, which is the correct answer. We'll just go ahead, submit our code snippet, make sure it works and gets accepted. So our code got accepted by Leetcode. It is almost 43% faster than other submissions which are done online on the performance side, and it is 14% faster on the memory usage. So this is the way we can solve this coding problem. Reachable nodes with restrictions, Leetcode 2368 coding problem, right? One another quite likable coding question and one recent one, right? A recent coding question. So I hope this explanation help you in understanding this problem with these examples and the explanation, and you understood the logic how we have solved this coding problem. If you are new to this channel and if you haven't already checked the very important playlist on this channel, then I would like to mention that there is a very important playlist on this channel. It is called as Leetcode and Leetcode solutions. That playlist is very important because it captures more than 250 different varieties of frequently asked coding interview questions. Those are the coding questions that got asked many times in many interviews. So make sure you go through all those videos, understand those problems, understand the logic to solve those problems, and also practice for the coding, how to code and solve those coding questions, right? Those are very important coding problems. If you go through those videos, you are going to learn a lot more about data structures, algorithms, problem solving, logic building, as well as how to approach and solve difficult coding problems and how to implement their solutions in Java. So if you go through those videos, it will really give you good practice, and as well as give you good preparation for your coding and in-person rounds of interviews. Also, if you check out those videos, you will also learn a lot about programming, especially in Java coding language, and you will also learn what are the frequently needed classes and APIs of Java that we often need during the implementation of solving different coding questions, right? So it will help you in your coding, improving your coding practices as well. So check out those videos. Those are very important videos. The name of that playlist is Leetcode and Leetcode Solutions. Now if you're still looking for more coding problems for your practice and for your learning purposes, then there are 3 other playlists available on this channel that you can use to prepare well for your coding rounds. The name of those other playlists are Code Forces, Code Shift and AdCoder. I'll repeat it: Code Forces, Code Shift and AdCoder. There are more than 500 different varieties of coding problems solved and explained using whiteboarding sessions for your easier understanding and grasping of different varieties of problems. So if you like this video, if you find this video helpful, and if this video helped you in understanding this lead code problem, reachable notes with restriction in an easier and better way with this description and whiteboarding session, then please give it a thumbs up to the video, give it a like to the video, subscribe to this channel. Your subscription is very important for the channel, because that is the way the videos can reach to more people who need help in solving coding problems. One of the main goal of the channel is to help people in their coding problem solving and in general their interview preparation process and in their learning process by creating content that others can use to prepare well for their interview rounds. They can use to learn different computer science concepts, data structures, algorithms, problem solving, logic building and Java coding. Then so if you like this video, give it a like, share it as much as you can with your friends and colleagues so they can also watch and learn from these videos. Apart from a lot of important coding videos, you will also see a lot of relevant interview related Java J2E videos available on this channel. For example, videos about frequently asked Java telephonic questions and how to answer them, Java architecture, Java design patterns, frequently asked SQL programming question, as well as Unix and KSH shell scripting questions to the Java developers. So those kind of videos are also available on this channel that you can use to prepare well for your coding rounds of interviews. If you like the videos on this channel, if the videos are useful and helpful to you, then please mention that by writing comment on these videos. Your comments are very important for us. That increases our motivation to create more such good quality content. So if these videos are helpful and useful to you, then do mention that into the comments. If you want us to create videos about any particular topic related to computer science programming as well as Java programming language, then also mention that into the comments as well. Keep coding, keep learning, keep solving different varieties of problems, and keep your learning process going on continuously. That is what is very important. And thanks for watching this video.